going to discuss, actually I'm going to continue my discussion on assignment problem, and I shall entirely dependent upon the board work. And I'm actually going to share the board where I'm going to write a question on assignment problem. Okay, so let's start. And you all be prepared with your copies. So my question is, first question is question number, just a minute. Question number 1, it says that you write the question. I'm dictating the question to you. You write it. I'm going to write the matrix only. Okay. Okay, let me write the question. This question is not very too long. Sorry.
Sir, we are giving an assignment. Attendance in the chat box. Okay, sir.
Yeah. Okay. A company has to assign. Four workers. A, B, C, and D. A, B, C, and D to 4 jobs W, X, Y, Z. The cost matrix is given below. Okay, and the matrix is like as given in the following: jobs. On the top of the table I'm writing jobs, cost in rupees. Under jobs we have 4 different jobs: W, X, Y, Z. And on the leftmost column we have workers. How many workers are there? 4 workers are there: A, B, C, and D. And the cost matrix is given as 1,000, 1,200, 400, 700, 600, 500, 300, 800, 200, 300, 400, 500, and lastly 600, 700, 300, 1,000. This is the cost matrix which is given in the problem. Okay, and our purpose is to the question is suggest an optimal assignment schedule the total cost pertaining thereto. This means you are going to assign the workers to jobs in such a way so that your total cost is minimized, because assignment problem is a minimization type of problem. This is the main criteria which needs to be satisfied. Okay, so I'm going to solve this particular problem right now, for which I'm going to use the Hungarian method. In my last class I actually discussed the development of the mathematical model corresponding to the assignment problem, and I also only solved one problem, one very easy problem, very basic problem, by using the Hungarian method. But now, right now, I am going to talk about Hungarian method in details, stepwise. The steps which were not, I gave you the steps, but still, today, the way I'm going to perform calculations on the given problem, this is more generalized than my previous attempt to the problem. Okay, so if you have an assignment problem in front of you, you are going to follow the approach which I am following today. The only difference, the only thing which I am going to talk about initially is about, just like we checked whether a transportation problem is a balanced transportation problem or an unbalanced transportation problem, first of all, by calculating the total availabilities and total requirements. Here also you need to check whether an assignment problem is balanced or not, first of all. So my step number one has to be, carefully observe, my step number one has to be check whether the assignment matrix is balanced or not. Assignment matrix is balanced or not. Okay, and how to check this particular criteria? For this, to check this criteria, we need to check only, we need to check, so it has become chick. We need to check whether number of rows in the matrix is equal to number of columns. Number of columns, or in other words, you can say whether the assignment matrix is a square matrix. Square matrix are such a matrix where number of rows and number of columns are same. If such is the scenario, we call the problem balanced. We call such a problem balanced problem. If the number of rows and number of columns are not same, then you cannot apply Hungarian method. Then in that case, we have to use something. We have to introduce dummy row and dummy column, just like we did in the transportation problem, to make it balanced. So first of all, you have to check whether the assignment problem is balanced or not. Criteria is number of rows of the matrix must be equal to the number of columns. Okay, what is the step number one? I mean the step number two that I gave you in my last class. I have to perform the row operation. In the last class, I actually started with this step number one. Now, according to the current situation, it has become step number two. So we are going to perform row operation. And what is row operation? What is row operation? Row operation is identify minimum element of the row and subtract it from all elements of that row, including itself. So this is called the row operation. This is called the row operation, which I am going to perform right now in the next page. Let me save your chat for your attendance, and then I'm going to do the row operations Uh, okay. Okay. So let me go to, can I, it would be better if I go to the next page. So I hope that you have copied the question and the steps which I have written over here. Okay. So let me go to the next page. Can I go to the next page? Someone please raise your hand.
Yes, sir. Yes, sir.
Yeah. Okay. Okay.
Yes,
So,
sir. Yes, sir. Yes, sir.
So my next, after row, my next step is my movement is from the next, I have to put the arrow mark like this. This arrow mark suggests that I am actually transforming my matrix from, I'm transforming my given matrix to a new matrix, and the new matrix is given as follows. So I have the columns W, X, Y, and Z, and the workers are A, B, C, D. Okay. And now you see in your copy, the matrix is written. So I'm going to perform the row operation in the first row. In the first row, the minimum element is 400. The first row, the minimum element is 400. So I have to subtract 400 from every other elements. So 1000 minus 400 becomes 600. The first element becomes 600. The second element becomes 800. The third element becomes 0. The fourth element becomes 300. So I have applied row operation like this on the first row. Similarly, if you go to the next row, the minimum element is 300. So I'm going to subtract 300 from all the elements of row B. So 600 minus 300 is 300. 500 minus 300 is 200. 300 minus 300 is 0. 800 minus 300 is 500. Fine. Then go to the next row, that is row C. Here the minimum element is 200. So we have got 200 minus 200, that is 0. 300 minus 200, that is 100. 400 minus 200, that is 200. 500 minus 200, that is 300. And in the next row, the minimum element is 300. So we get 600 minus 300 as 300. 700 minus 300 as 400. 300 minus 300 as 0. And 1000 minus 300 as 700. So we have got this particular matrix after performing the row operation. This is my new matrix. Okay, you can call the previous matrix, the given matrix, as your matrix 1. This is your matrix 1, and you can call your new matrix to be, matrix 2. I am going to apply step number 2 on the matrix 2. So perform column operation now. Perform column operation now on matrix 2. What is the column operation? Identify by identifying minimum element of a column and subtract it from all elements of that column, and repeat the process for every column, just like we repeat the process of row operation for every row. We have to repeat it for every column. So we have to put an arrow mark like this, and I'm going to write the new matrix by using step number 2. So sorry, this step will not be numbered as 2. This step will be numbered as 3. Okay. So this is my, actually this is my step number 3, not 2. So let us write the new matrix. So we get W, X, Y, Z and A, B, C, D. A, B and C, D. Now we shall, I'm going to start with the first column, and then I shall gradually move on to the next column and next column, and I shall cover all the 4 columns as given in the matrix, matrix 2. So you see, in the first column, the minimum element is 0. And I'm going to subtract the minimum element from every element of that column, including it. So actually, I'm going to subtract 0 from 600, 0 from 300, 0 from 0, and 0 from 300. Actually, the column, there will be no change in the column 1 of the new matrix. So I'm going to write the column as 600, 300, 0, and 300. That's it. In the next column, the minimum element is 100. So I'm going to subtract 100 from every other element. So you get 800 minus 100, that is 700. 200 minus 100, that is 100. 100 minus 100, that is 0. 400 minus 100, that is 300. Fine. Similarly, the column 3 will not change because here the minimum element is 0. So there will be no change in the column 3. And column 4, the minimum element is 300. So that will be subtracted from other elements. So we get 300 minus 300, that is 0. 500 minus 300, that is 200. 300 minus 300, that is 0. And 700 minus 300, that is 400. So you, by this operation, actually we have got our matrix 3. Now I'm going to write step number 4. So what we need to do now, we have to assign zeros by putting them inside a square box. And how to perform this? We shall try to look for a row or a column which contains single 0, and we assign it. If there are any other 0 in the column and in the row containing the assigned 0, those zeros must be striked out. Okay, so this is my step number 4. So I'm going to apply my step number 4 to the given matrix. Okay, so how to do it? I'm going to scan the matrix. Matrix means I'm going to scan the matrix M3 in such a way so that I have to find a row or a column which contains a single 0. But I shall not do it haphazardly. I shall go sequentially. First of all, I'm going to check the first row, and I'll try to look for whether the first row contains a single 0 or not. If not, then I'll go to the next and I'll check whether that row contains single 0 or not. If there are no such rows which contains a single 0, then I shall start with column checking. I shall look for the single zero in the first column. I shall look for the single zero in the second column, and so on. Okay. So you see, if I go by this sequential method, if I start with the first row contains 2 zeros, and I need to find a row which contains a single zero. So first row is not my desired row. Then I go to the next row, that is second row, that is B row. B row contains a single zero. This is the zero which is being contained by row B. So I'm going to assign it by putting it inside a box. And what else is written? It is written that this assigned zero, try to check whether the assigned zero, the zero which is situated somewhere in the row and column of the matrix, in that row or column which contains the assigned zero, whether any other zero is there or not. If there are any other zeros in that column or in that row containing the assigned zero, strike it out. Now this assigned zero is situated in this row. In this row there is no other zero, so we don't have to worry much. But here we see this assigned zero is being contained by this column, and this column has 2 other zeros in it. So I have to strike out these zeros from further calculation. Why? Because assignment theory says that in every row and in every column there must exist exactly 1 zero and not more than that. Okay, so therefore, since this zero has been assigned, I have to strike out other zeros in the column or in the row containing the assigned zero. Now I have to check again, once again, for the rows and columns which contains the single zero. The question is, how long should we check step number 4? We should keep on checking. We should keep on checking until we get assigned zero in every row and in every column. Okay, that is the checking criteria. That is the checking criteria. Okay. So once after this process, I am again going to repeat the process on the rows and the columns. So I am again going to start with the first row. Now you see in the first row, after striking out, after the previous step, in the first row there is a single zero. This row now contains a single zero. So I'm going to immediately assign it. Now this assigned zero is being contained by this row, and this row has no other zero. But this assigned zero is being contained by this column also, and this column has a single zero in it, another zero in it. So I'm going to strike it out. I'm going to strike this particular zero also. So we have got 2 assignments, but we have to keep on checking further because there are still zeros in the matrix which have not been assigned. Okay. Now the first row is assigned, the second row is assigned, the third row I cannot make an assignment because the third row contains 2 zeros, and I need a row or a column which contains a single zero. The fourth row contains no zero at all. Okay. So row checking is done, but zeros are still present. So I have to go for column checking. So suppose I start with column 1. Now you see that in column 1, there is a single zero. This is the zero, only zero present in column 1. So I'm going to assign it. Okay. And just like my previous example, previous case, I need to check whether this in the column or in the row containing the assigned zero, other zeros are present or not. So you see that this assigned zero is being contained by the row C which contains another 0. But since the 0 has already been assigned in the row, we cannot assign it, so we are going to strike it out. So now you see, after this step, the matrix, we are left with a matrix M3, which has got 3 assignments in it. The matrix has got 3 assignments. So can we say that our job is done? The answer is, our job is not done, as D row or X column has not got any assignment. Has not got any assignment. So I am going to do something now which has not been discussed in my previous class. Okay, so that is why I told you that it is the generalization. I have to I'll say that I have got my optimal assignment only when I get assignment in every row and in every column. But here you see that there is a, here I can see that there is a row and a column which has got no assignment at all. So my job is not done. So I'm going to do something right now on the matrix M3. For that, I need to write the matrix M3 without assignment once again. So I'm going to do that on the next page. Okay. So let me write the matrix. I'm writing the matrix M3 now once again. So the columns are W, X, Y, Z, A, B, C, and D. Okay. And the matrix elements are 600, 700, 0, 0, 300, 100, 0, 200, 0, 0, 200, 0, 300, 300, 0, 400. But I shall not write any assignment. I shall not write any assignment. Rewriting of matrix M3. Rewriting of matrix M3 without any assignment. What is my step number? What is my step number 5? What I'm going to do right now? Because in the previous step I have not got my desired number of assignments. So my step number 5 says, check how many assignments you have got in the previous step. Suppose there are small k assignments. Which is not the desired number of assignments. Okay, then try to draw small k number of horizontal and vertical lines to cover all the zeros in the matrix M3. This is the step. So I'm going to perform this step. What is this particular step is saying? The step is saying that I have to check that how many assignments I have got in the previous step. In the previous step, my desired number of assignment is 4 because there are 4 jobs and 4 workers. But I have got my assignments, the total number of assignments I have got is 3, and 3 is less than 4. Okay, 3 is less than 4. So what I'm going to do, just a minute. Okay, so what I'm going to do, I'm going to draw, according to the rule, I'm going to draw 3 lines. I'm going to draw 3 lines in such a way so that it covers the lines cover all the zeros present in the matrix, but the number of lines should not be lesser than 3 or greater than 3. Why? Because of this rule. It is actually a theorem. The number of lines to cover all the zeros in the matrix must be equal to the number of assignments which is possible in the given matrix. At present, the matrix is characterized in such a way that more than 3 assignments is not possible, or less than 3 assignment is also not. Less than 3 assignment is not actually required, but more than 3 assignment has not been obtained. So your number of lines drawn and number of possible assignments must be similar. Okay, but you can draw the lines. Number of lines is 3, must be 3, but you can draw the number of lines horizontally or vertically. But while drawing the lines, you have to keep in mind that it should not exceed 3. Okay, so I can do what I will do. I will try to find out a column or a row which contains maximum number of zeros. So you see, if I look at this column contains 3 zeros. So I can draw a vertical line like here. This is line 1, so that it covers all the zeros present in the column. So I'm going to do that in the following way. I'm going to draw a vertical line like this. Okay, this is my line 1. Then I see that this row contains maximum 0. 3 zeros are there. So I have to cover these zeros. So I can draw a horizontal line like this, and I can consider this line to be my L2. Okay, and now you see, if this row contains 2 zeros, 1 zero has already been covered by the line. So this row contains a 0, and you can say that this column is also contain a 0. Okay, so this 0 needs to be actually covered by a line. Now it is your choice whether you want to draw a horizontal line or a vertical line. You can draw the remaining line, that is line 3, in this manner also, or in this manner also. Whatever, it is your choice. It is an arbitrary choice to be made. So without any loss of generality, I am going to draw the vertical line like this. Okay, so this is my line 3. I am again repeating. I have drawn the last line, that is line 3, vertically, but there was another choice which could be made. You could have drawn the line horizontally. Okay, so that choice has been made just arbitrarily. Okay, but I have to keep in mind that the lines drawn to cover all the zeros in the matrix must not exceed the assignment made in the previous matrix. In the previous matrix, there were 3 assignments. So max to max you can draw 3 lines. Max to max you can draw 3 lines. Okay. So,
Sir,
Bolo, tell me.
sir, that L3 line that you have drawn, if suppose instead of drawing it vertically, if we take it horizontally, then the answer will come different, or will it come same?
Now, if you draw it, since I have drawn two vertical lines and one horizontal line, and if you like to draw two horizontal lines and one vertical line, then what will happen? Both of us are going to get the same answer ultimately, but maybe by the number of tables drawn by me, then remaining I have to draw number of tables further, which will be more than the number of tables drawn by you. I don't know whether which one of these two will be the correct approach until and unless I actually proceed. So it may so happen that after this current drawing, I have to figure out two more tables to get the answer. And if you draw the if you draw the lines in your way by drawing more horizontal and two horizontal and one vertical, then maybe you shall be requiring more than two matrices to reach to the solution. But ultimately, both of us are going to get the to the same point at the end of the problem. At the intersection point of will remain same. Okay, so number one, the market is number one. The covered lines is also very important. Some present condition part of the and to make it part. Okay, so let's do one new select 9 and 4. I'm going to mix Z, B, C, and D. According to the rule, and this zero has been covered by line. This zero covered by the line. So zero. This zero has been covered by the line. But they actually like the intersection of the line. So therefore it is x1 actually like number 2. Try to identify the all points of all uncovered elements. Identify uncovered elements. So 70, 100 is the best state. Minimum 100. So I what to do? Subtract the minimum element from other uncovered including itself. Okay. I'm actually what about the intersection the minimum at the minimum uncovered element to the elements of the intersection point. Sorry, I'm writing here of the intersection points. Okay, so what is my minimum element? My minimum element will be, my minimum element, uncovered element is 100. So actually I'm going to add 100 to this, and I'm going to add 100 to that. So my, after this operation, I can name this operation as say for example, let us name this operation. The first one is 1, the second one is 2. This is my third operation actually. Okay, so I'm going to perform that third operation, and by this I get my new set of elements as 100 plus 200, that is 300. 100 plus 0, that is 100. What is happening actually? Now, this particular step, interestingly, you note down this step carefully. What is this step? What is this step number 6? Do we know this step number 6? Is it a new or something which has been done earlier? Try to identify. You are going to get a kind of very beautiful thing out of this scenario. When we applied transportation problem, in the transportation problem, we used Vogel's approximation method or any other method to find the initial basic feasible solution. After finding the initial basic feasible solution, we were not sure whether the solution was optimal or not. So we had to check the optimality by the modified distribution method. While checking the modified distribution method, if it indicates the solution obtained by any of the transportation method is not optimal, what we did, we actually applied the method of looping. And with the help of looping, we distributed the allocations in such a way that some allocations were actually changed. Previously, there were some values and now the value has been increased or decreased. What else happened? What else happened over there? You got some cells which earlier had allocations, but after your modified distribution looping performance, those allotted cells became unallocated, and also some unallocated cells were there in the initial matrix, which after performing looping got allocated. The same scenario is happening over here. The same scenario is happening over here. Some elements were 0, some elements were non-zero. These elements are actually becoming 0 in this new matrix, and some elements were 0, which are getting non-zero value in the new matrix. So actually, something like modified distribution is actually happening over here. And this particular step, nobody thinks about it, nobody says anything about this particular point. This particular step is actually says that it is the indicator. This says that actually we are performing the optimality testing over here, and therefore we say that Hungarian method is an optimal method. After applying Hungarian method, we don't have to go for extra optimality checking. Okay, but nobody actually, I have seen in the various classes, the teachers actually avoid telling this particular situation in the classroom. Maybe they actually don't want to get into the details and don't want to make the students confused, or maybe they miss somehow. But this is the thing why I can say that the Hungarian method is the optimal method. Extra optimality checking is not required. So this is, you can say that this is my new modified distribution matrix of zeros, where I can make my assignments once again. Now, in step number 2, in this particular step number 4, actually we did the assignments. So we are after applying step 6 and after getting my matrix M4, I am going to apply step number 4 once again on it. So my next job is to write this matrix M4, and then I'm going to apply the step 4 on it to see whether desired number of assignments can be made or not. So I'm going to go to the next page. So first of all, let me copy the matrix. So the matrix is my new matrix is M4, and the columns are W, X, Y, Z, and A, B, C, and D. These are the workers, and those are the jobs. And what were the matrix elements? 500. Matrix elements were 500, 600, 0, 0, 200, 0, 0, 200, 0, 0, 300, 100, 200. Oh, I forgot. 200, 200, 0, 400. So again, I'm going to perform the same old operation discussed in step number 4. So let us start with row 1. Row 1 means row A. Row A contains not a single 0. So I cannot make an assignment over here. Go to the next. Row B contains no single 0. Cannot make assignment over here. Next. Row C contains Row C contains next two zeros. Okay, so I cannot make assignment over here. Go to next. Row D contains a single zero. So I'm going to assign that zero. And this zero is actually appearing in this column and in this row. In this row, there are no other zeros, but here I can get two more zeros in the column containing the assigned zeros. So I'm going to strike them out. Okay. And then I'm going to check again row wise. You can also check column wise. So if you ask me this, sir, please check column wise. So I can do also. Say for example, if you want me to check column wise, then I must say that the column Z contains a single zero. But also, if I go row wise, that is row A contains a single zero. That means whether you go column wise or row wise, you are going to get ultimately reach to the same point, same milestone. So I am a bit attached to rows, and therefore let me check row wise. So I can, from the perspective of row operation, this row contains a single zero and I can assign it. And this assigned zero is appearing in this column and in this row, and there are no other zeros. So we don't have to worry much. Next, we come to the row B, and now this row B contains a single zero, and therefore we can assign it. This assigned zero is appearing in this column, and in this row. In this row, there was another zero which has already been striked out. But in this column, which contains this assigned zero, another zero is appearing. So we are going to strike it. And lastly, we have got a row which contains a single zero in it. So we have no other choice but to put an assignment around it. When I am actually, I am coming to that point later on. Let me finish the problem first. So now you see at this stage, we have got at this stage, we have got 4 assignments, and that is exactly equal to the number of, that is exactly equal to the number, I shouldn't write number of, that is exactly equal to the order of the matrix. Order of the matrix. That is exactly equal to the order of the matrix. Okay, and this, by this you can say, by this we can say optimal assignment has been reached. Optimal assignment has been reached. What is the optimal assignment? Okay, so what assignments you have got after the performing all the operations? So assignments are like this. So the worker, let me write it in this manner, otherwise then you will be able to understand it very properly. Worker and jobs, or jobs and workers, whatever, in any direction. So workers are A, B, C, and D, and jobs. Now A is assigned to what? This A is assigned to Z. That B is assigned to X. That C is assigned to W, and D is assigned to Y. So that means the worker A is going to perform the job Z, then the cost for performance will be lesser than the other if other people do this particular work. Try to recall the John Klein example which I did in my first class of assignment problem. Worker B is good, it is better to assign job X to worker B. It is better to assign worker C to job W, and it is better to assign worker D to job Y, or job Y to worker D. And what is the total cost? What is the total cost? How to calculate it? Total minimized cost. I'm going to calculate right now. Total minimized cost. So for this, I have to put another column. Okay. And I'm going to write the costs over here. Okay. Costs in rupees. So you see, go to the next. I'm to write the costs. I'm going to take reference from the very first matrix which is given in the problem. I'm going to take the costs from this matrix and not the other matrices from M2 to M5. My actual matrix is this one. Okay. So I'm going to take the costs from there. So when A goes to Z, then the cost is, when A goes to Z, the cost is 700. When B goes to X, the cost is 600. When C goes to W, the cost is, oh sorry, I've made a mistake. When B goes to X, the cost is 500. When C goes to W, the cost is 200. And when D goes to Y, the cost is 300. So we are going to get the total cost as rupees 0, 0, 7 plus 3 is 10, plus 5 is 15, plus 2 is 17. Rupees 1700 is the minimum cost of my, with respect to my optimal assignment. And my job is done. And my job is done. I'm happy. So actually what is happening when I assign something? Let me talk about the assignment now. When I assign something, the assignment, the performance, Hungarian method, the assignment performance is very important. So when I make assignment, so what we do, if we want to compare the thing with respect to the transportation problem, in transportation problem, we take items from the factories and we allot the items to a particular destination. Okay. This number of items may be different, any non-zero. Here also I am doing the same thing. Here also I am putting 1 when I'm assigning, when I'm assigning 0, when I'm assigning a 0, a box, actually I am putting 1 from here and I'm giving 1 over here. I'm giving 1 over here, and here the assignments are 0. Okay. When I'm assigning this 0, that means I'm putting my 1 over here and other assignments are 0. When I'm assigning this, my 1 is this, my other assignments are 0. When I'm assigning this, my 1 is there, my other assignments are 0. So actually I am doing the same thing which I did in the transportation problem. Okay, I'm allocating things. Okay, so this is how the this particular methodology that you are supposed to follow in any assignment problem. This methodology must be followed in any assignment problem. Okay, hope you have understood the first problem which I have discussed. Let me take a new problem, a new type of problem. Okay, so let us select a problem. Here I am sitting with on my left side there is a book has been opened. On my right side there is a book. Now I'm going to scan the books a little bit. Okay, and let me check whether I can find a new type of problem from there. The book actually I am holding, I don't know whether you can see or not. This book is has been actually inverted, Linear Programming Problem and Theory of Games by PM Kadak. So let me find a problem from here, from the exercise. So just a minute, hold on. I want to solve a problem which is of different type. Okay, so yeah, I have got one problem in the exercise. It is something different, but don't worry much, because I'm not going to talk about any new steps right now. I'm going to apply the very old steps which I applied just now, but problem is structurally different from my other current problem. So I'm going to write the table only. I'm not going to give you the entire question. The table. The problem is like this. And now I'm not going to write the steps, because the steps are now known to you. So I am going to write the matrix only. Okay. And this is my, hope you are understanding, because I cannot, you are sitting very quietly. Let me, okay. You are sitting very quietly, and therefore I think that you are understanding what I mean to say. Oh, let me change the name of the machines operators like this. Operator 1, operator 2, operator 3, operator 4. And the values are given to be 5, 5, dash 2, 7, 4, 2, 3, 9, 3, 5, 9, 3, 5, dash 7, 2, 6, 7, 7, 2, 6, 7. This problem is a special type of problem. Why? Because you see this part and this part. I have put this in these parts, in these two sections, dashes are there. That means it is a kind of, this problem is a kind of restricted assignment problem. Restricted assignment problem. Restricted assignment problem. Okay. What is the restriction? The restriction is operator 1 cannot be assigned machine 3 for some reason or other. I don't want to know. We don't want to know. And operator 3 cannot be assigned machine 4. With these restrictions, what will be my optimal assignments? With these restrictions in mind, what will be my optimal assignment? So I must say to you that Hungarian method, in this case, Hungarian method will remain same here, but throughout the process, these dashes will remain as dashes. There will be no change. These dashes will remain as dashes. You can draw lines over them, but okay, the dashes will be covered by the lines. If this particular dash comes in the intersection point, then also there will be nothing. So I'm going to write those points.
So sir,
bolo.
in the in this sum, then if we go for matrix 2, that is row operation. So in
Okay,
that
let me perform the row operation. Let me show you the row operation, and you will understand. Okay, let me write machine M, and that stands for O. So let me show one thing. MO, we have 1, 2, 3, 4, we have Roman 1, Roman 2, Roman 3, Roman 4. I am going to perform row operation here. Row operation. Okay, very good. Let us solve it. Now, in this particular row, which one is the minimum element? How many elements are there? 3 elements are there. 5, 5, dash 2. Dash is not an element. So 2 is the minimum element. So I'm going to subtract 2 from every element and including itself. Okay. So 5 is an element. So I'm going to write, since 5 is an element, I'm going to subtract 2 from 5. So I get 5 minus 2, that is 3. 5 minus 2, that is 3. 2 minus 2, that is 0. A dash is not an element at all, so it will remain dash. So I hope Akash got his point. In the second, 2 is the minimum element. So 2 will be subtracted from every other element. So 7 minus 2, that is 5. Then the 4 minus 2, that is 2. 2 minus 2, that is 0. 3 minus 2, that is 1. And here the minimum element is 3. So I'm going to subtract 3 from every other element. So 9 is an element. So I write 9 minus 3, that is 6. 3 minus 3, that is 0. 5 minus 3, that is 2. But dash is not an element, so it remains dash. Here similarly, 2 is a minimum element, so I'm going to subtract it. So we get 7 minus 2, that is 5. 2 minus 2, that is 0. 6 minus 2, that is 4. 7 minus 2, that is 5. So you see, after performing the row operation, dashes have not changed. Dash is the restriction. The door is closed. We cannot do anything to it. The door is closed. Okay. Then if you want to perform the column operation, let me show you another column operation. Then what will happen? Let me show this particular part. And we have this 1, 2, 3, 4, and we have operators 1, 2, 3, and 4. And now column wise, first column contains minimum element as 3. So we have got 3 minus 3, that is 0. 5 minus 3, that is 2. 6 minus 3, that is 3. And 5 minus 3, that is 2. In the second case, the minimum element is 0, and then the elements actually will not change because minimum element is 0. In the second one, the minimum element is 0. So I will write 0 here, 2 here, 4 here, but dash will remain dash. Here minimum element is 0. Then I will write 0 here, 1 here, 5 here, but dash will remain dash. So you see, there will be no change in the dashes. No change in the dashes ever. Whatever you do, there will be no change in the dashes. Remember this. Remember this point. No change. No change in the dashes. No change in the dashes. Okay. So these dashes, these doors are actually closed. You cannot do anything to it. Any operation earlier defined cannot be performed on it because this is a restriction. Danger. Don't go. Danger. You cannot do anything. And dashes are not at all elements. We perform row operation, column operation on elements. Dashes are dashes. They are not elements. Door closed. You do not know what is it. Okay. Entire thing which I have discussed previously will be same throughout. So I hope that you will be very much happy to solve this problem. You can do it. You will be smart enough to solve the remaining part of the problem. So I must write here, it is a homework. What should I write? Do it by yourself.
Okay. Class
No. Another problem. Then we have another problem. Let me take another. Yeah, I have got one. So it's a new type of problem. Class shesh hobe ক্লাসের টাইম যখন শেষ হয় 5টার সময় শেষ হবে, তার আগে খালি অঙ্ক করে যাব আজকে, প্রচুর অঙ্ক করব। J1, J2, J3, J4, এটা কিন্তু this is another type of problem. Okay, A, B, C. Aren't you happy, Akash, with the problems?
No, sir, it's okay. It's okay.
So it's another type, is very important type. Are you enjoying? That I want all of you to enjoy. So it is 10, 12, 8, 6, and 6, 9, 12, 14, and 3, 8, 7, and 12. Here you see this is a very special type of problem in the cases, because in this problem the number of rows is not equal to number of columns. Okay, it's a special type of problem. So we call such a problem unbalanced. To apply Hungarian method, we have to first make it balanced. Now, if small r, sorry, let me write it with a different color. If small r is the number of rows and small c is the number of columns, and if r is less than c, if the number of row is lesser than the number of columns, then what we do is that c minus r row is added with all 0 elements in it. Such a row is called dummy row. Such a row is called dummy row. Okay, say for example, in this particular case r is equal to 3 and c is equal to 4. R is equal to 3 and c is equal to 4. So 4 minus 3 is equal to 1, and therefore I am going to introduce one row extra, which I shall denote by, say, D1. Okay, and this is my dummy row. This is my dummy, and what will happen over here? I will write all the elements 10, 12, 8, 6, 6, 9, 12, 14, 3, 8, 7, and 12. Okay, but the dummy elements or the elements present in the dummy row will be 0, 0, 0, 0. Just like we do in the case of transportation problem. Dummy elements are all zeros. Okay. And if number of column, that is C, is less than R, which is number of rows, then R minus C columns is added with all zero elements in it. Such a column is called dummy column. Such a column is called dummy column. In this current problem, number of row, as I've already told you, it is dummy row has been used. If I give you another problem, there you will find that the dummy column will be used. Okay, so such a problem is just a same type where only the dummy columns will be there. Okay, and the most important point is that rest of the problem will remain same. Rest of the part will remain same. So all the methodologies I explained in the first problem will remain same throughout for this particular problem. Everything will remain same. So I am pretty much confident that you also smartly can solve this particular problem. You can finish this particular problem. So this is your also homework. Okay. Let us go back to the next problem. Next problem is very interesting problem. Okay. So let me write the question first of all. I am taking another book where I have the question with me. It's also given in the assignment note, which I shared with you in the previous session. The problem is pretty interesting, and it is actually called AlRLINE CREW assignment problem. AlRLINE CREW assignment problem. This is a very practical scenario. You will find it very interesting. AlRLINE CREW assignment problem. I have been teaching in Technomain Salt Lake for last 14 years, and several times I have said this particular problem as a question in the examination. When I was asked to I was asked to actually make a question for the examination, but during this past 14 years, this question has never been selected in the examination, because I think the moderators of the question moderators, they are also not comfortable with this particular problem. They think that students will not be able to solve it. I am pretty much doubtful whether they can solve it or not, because students, they are students, they are neglected. Students are very smart. If you teach them something properly, then students can do everything. But teachers, when they cannot do anything, they say the students can. This is a very hard problem for the student. Have you tried the problem with the student? Have you asked the student whether they can solve it or not? So unfortunately, this problem has never been selected in the question paper. But if you go to the practical field, this question has very tremendous amount of practical relevance, and you will be able to feel how assignment problem is used in the practical scenario. So although it's very neglected problem and very, I mean, not very unpopular problem, so I'm going to solve it for you right now. If I can finish the problem in today's class, okay, but if I cannot, I shall continue in the next class. I will be able to finish this problem in the today's class. Let me write the question. An airline that operates 7 days a week has a timetable shown below. Has a timetable shown below. Cruise. Who is writing what? Let me check. Ritik Chakraborty. Now joined. Very good. Crew must have a minimum layover. This particular word means resting time. Layover of 6 hours between flights. Very good. Obtain the pairing of flights. Obtain the pairing of flights that minimizes layover time away from home. For any given pairing, the crew will be based on the city that results in the smaller layover. Now I am going to write the table chart. Flight number 1, 2, 3, 4. Delhi to Kolkata. Departing time, depart and arrive. And we have flight number. This is one of my favorite problem because I can relate it to the practical picture. It's one of my most favorite problem. And we have Kolkata to Delhi. After the problem is done, that problem is going to become your favorite problem too. Depart, arrive. Very good. And see, one interesting thing is that Delhi to Kolkata, flight numbers are 1, 2, 3, 4, and we very well know that when we come back to Kolkata from Delhi, then the flight numbers change actually. Probably we have noticed. So actually, so the flight number 1 has become flight number 101, the flight number 2 has become flight number 102, like this. I'm going to write the times now. 7 a.m. and 9 a.m. Here we have 9 a.m. and 11 a.m. Then we have 1:30 p.m. and we have 3:30 p.m. and be ready with your calculator, students. If you have calculator, then be ready with it. Be ready with it. Keep your calculator in front of you. You will understand why am I saying this. 10 a.m., 12 noon, 3:30 p.m., 5:30 p.m., 8 p.m. and 10 p.m. Let me draw the vertical lines, otherwise shit. Okay, this is one line, this is another line, this is another line. Now you can understand. What am I supposed to find? I am supposed to find for each pair, also mention, it is the extra part actually, also mention the town, also mention the town where the crew should be located. This part, which has been marked as star, this part can only be done after we finish the problem, not before that. So we are not going to, I'm not going to think about this part right now. It is secondary. Main important portion, try to look at this problem very carefully. This particular problem asks you to do assignments in such a way so that we get minimum layover time. Why am I going to do the assignment? I am going to do the assignment in such a way so that we get to minimize the layover time. But what assignment? How to assign? That is very important thing, because in the previous 3 examples, we got the matrix in front of us. We got the matrix. We got the rows, we got the columns, we assigned in such a way, in some ways or other. But here that matrix is not given to you. Rather, say a situation is given to you. First of all, your job is to construct that matrix. Okay, so for this construction of the matrix is very important. So I'm going to do the construction over here. Construction. If you do not construct, then you will not be able to solve the problem. And for the construction, in the construction, I'm going to perform 3 steps. Step 1, 2, and 3. These steps are not the steps of Hungarian method. These are the construction steps. Okay. My first table number 1. Table number 1. Let me give it a name. Layover time when, layover time when crew is in Delhi. The crew is in Delhi, the layover time. Now carefully observe what am I doing. Let me write the matrix first of all. rows and columns. Okay, this is my, I'm going to assign flight to flight. Okay, remember the crew is now based in Delhi. The crew is now based in Delhi. Okay, so I'm going to construct my table 1. Now here you see that, first of all, try to understand. A flight is departing from the airport, Delhi airport, at 7 a.m., 7 in the morning, and it's coming to Kolkata at 9 in the morning. It's very true picture, because if you take Indigo flight, then exactly 2 hours is required for the flight to reach to Kolkata from Delhi. Okay, I once been to Delhi, once visited Delhi by Indigo Airlines. Okay, so 9 a.m. the flight arrived at Kolkata, and it departed from Kolkata at 9 a.m. So obviously this 9 a.m. is not the 9 a. These two 9 a.m.s are different, because it is not like that the flight is coming like this and then again throwing all the passengers out in the all the passengers out on the runway. It again is it's taking off. It is not like that. Okay, so obviously the time between these two is actually 24 hours difference is there. Okay, so if hour wise it is 24, so you can put 24 over here, but there are certain times you can see later that where you have to put fractional hours, like 6.5, 7.5, these will come. So you can avoid fractions in the following way. You can consider this, that 1 minute is equal to 1 unit. Okay, this is a pretty homework, where you can say that, and we know that 60 minutes is equal to 1 hour, and we are going to construct our, if I get any hour, then that will be converted to 60. Okay, so that's why I asked you to sit with your calculator. So you will, some of you, one of you, please unmute yourself, and I will ask you I will tell you the values, and you will please use your calculator and tell me what values you are getting. Okay, so if I consider 9 to 9, then the difference is 24 hours, and 24 into 60 is how much? Anybody?
Sir, 1440.
Yeah,
1440.
yeah, 1440. So this is my first value. Then I have to assign 1 to 102. Now you see 9 a.m. to 10 a.m. So obviously this is the next morning. So the difference is 25 hours. So 25 into 60, how much?
1500.
1500. Put here.
100.
Then 9 a.m. to 3:30 p.m. Now, when it is 3:30 p.m., from 9 a.m. to 3:30 p.m., this 3:30 p.m. is not the 3:30 p.m. of the next day. Why? Think of this. Minimum layover time is 6 hours. So if you get the difference between 9 and 3:30 to be 6 or more than that, then you will consider that 3:30 p.m. of the same day of 9 a.m. Otherwise, if it is not so, if it is lesser than this, you can take the 3:30 to the next day. So 10, 11, 12, 13, 14, 15, 6.5. Multiply 6.5 by 60. How much?
390.
390 is the next.
390.
Yeah, 390 is the next value. Then we have 9 a.m. and 8 p.m. So this is 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 11. Multiply 11 by 60, 11 by 60. So it is 6,660. It is easy. I can do it myself.
660.
Then I have actually assigned this in this manner. Now I am going to do it for 2 to, I am going to assign all these flights with to 2. Okay, so let us do it. You also try by yourself. Now it arrived in Kolkata at 11 a.m. and it departed in the 9 a.m. So this 9 a.m. is definitely of the next day. So we have 12, 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 22 hours. So how much you are getting?
22.
22 into 60.
1320.
1320.
1320.
Yeah, okay. Then similarly, you find the other numbers and tell me. Tell me other numbers. If you have any, if you find any difficulties, then you ask me. I'm going to tell you, and let me do it from my end. And then if you find that your values and my values are mismatching, then you immediately point it out, and I'm going to or you some of you can tell me the values, and I'm going to write it. Others can check whether the person is telling it rightly or wrong.
1380. Sir, 1380.
1380. I'm not calculating, I'm just writing, copying now. So others, please check whether he is right or not. If you do not consider the minutes, if you consider hours, some values will be just non-fractional, some values will be fractional. You could have taken hours also, no problem with that. We can do the calculation with hours, but I don't want to bring fractions into the picture. So next one.
Yes, sir, counting.
Others, please also do. 22130 to, so 111 am to 3:30, so 12 11 12 1 2 3. Achha, one thing, when you want to connect these two, when you want to connect these two, you see the gap is not 6 hours, it is lesser than 6 hours. So that 3:30 is not the 3:30 of the same day, it is the 3:30 p.m. of the next day.
Next day.
Yeah, so 11 am to 11 am you get 24 hours, and then extra 12 1 2 3 4, so 2 1 2 3 12 1 2 3, so 4.5. So 12 plus 24 plus 4.5, 28.5, 28.5. Multiply 28.5 by 60. Tell me what is the value.
1710.
Yes, that is the right. That is all right. 1710. Then you take the difference between 11 am and 8 p.m. See, if it is less than 6, then you have to count more. If it's more equal to 6, then you are all right. 12 1 2 3 4 5 6 7 8 9 into 60.
9
9
into 60.
9 hours.
540.
540. Okay, 540. Then finish the next. Now you associate 3 with others. Now you associate 3 with others. Okay.
স্যার এটা তো কম হলো কেন?
তো হোক না, কি অসুবিধা হচ্ছে?
না না স্যার, আগেরটা যেটা 3:30 যেটা হলো, যেটা 28.5 আওয়ার্স হলো, এটা 8 PM হলো, এটা সেম ডে হয়ে গেল তো?
হ্যাঁ হবে তো, কারণ because the thing is that when the minimum layover, see you, what is the difference between, if you take 8 PM of the same day and 11 AM, then what is the difference? The difference is how much? 9 hours. The flight actually requires 6 hours of minimum layover time. So if it is more than that, then I have to consider, I shouldn't consider. Now 9 is, if you consider the 8 PM of the same day, the difference is 9 hours. If you consider the 8 PM of the next day, the difference will increase. Okay, then you can ask me, in both the cases it is greater than 6 hours, which one I should take? I obviously will not allow you to select the next day, because already the difference is 9 hours difference, and the airline crew is getting the minimum layover time of 6 hours. So if you increase it intentionally, then obviously your assignment problem, your thing will not be minimized. So therefore I have 9 if I consider the same day. I have more than 9 if I consider the next day. So I am considering 9, and it is also satisfying that the minimum layover time is actually being fulfilled. But in the previous stage, the difference of these two was less than 6, and that should not be, because if a flight if pilot doesn't get sufficient amount of rest, then there will be a trouble, there may be accidents. So this was lesser than 6 hours, and therefore we had to take 3:30 to the next day. Therefore this value was larger than this value. So tell me the other values. Now what happened? Why so quiet? Why so serious?
No, sir, counting the
Okay, count.
3:30 to 9
3:30 to 9. 3:30 p.m. to 9
p.m.
means you go 4:30, 5:30, 6:30, 7:30, 8:30, 9:30. See, you if you go if you from 3:30 to 9, if you move from 3:30 p.m. to 9 a.m., you have to go to 9 a.m. means next day. A.m. it is there a.m. So 4:30, 5:30, 6:30, 7:30, 8:30, 9:30, 10:30, 12:30, 1:30, 2:30, 3:30, 4:30, 5:30, 6:30, 7:30, 8:30 means 16.5. Multiply
16.5
multiply 16.5 by 60. How much you are getting?
990.
Yeah. Then no, let me check once again. Have I done correctly? 3:30 to 9 a.m. So 3:30 to 9 a.m. 4:30, 5:30, 6:30, 7:30, 8:30, 9:30, 10:30, 11:30, 12:30, 1:30, 2:30, 3:30, 4:30, 5:30, 6:30, 7:30, 8:30. 17.5 multiply 70. Yeah, 17.5 by 60.
1050.
Yeah, that is true. That is all right. 1050. Then next
3:30 to 10.
others, please help him. Akash. Oh, Bindu Yadav has told. Which one? 1100 Bindu? This one? Triple 10. Which one, Bindu? Okay. Not replying. See, Bindu has written that something is 1110. So I have written it. Calculate. Probably she's saying that this is 1110.
I think that one will be 1080.
This one?
The second,
Oh, let me check. Bindu. Not replying. Okay, let us solve it. What is she saying?
One friend is writing Aditya Somchodri.
Aditya Somchodri. He has also got 1110.
Okay, then
probably they are right. Probably they are right. Let us write it. What was written? What was written?
1440 1710. 1440 1710.
10. Okay.
Hmm.
Now, others, please help with the last row. Probably they are angry with me.
932.
Yeah, they are just saying that when I got Sobik sir face to face, we meet him, I will teach him lesson for making us. Let us find him somewhere. Others, Aditya, help. We need help. Aditya, Mousham, Shubham. Kaustav is not there. Kaustav is sitting quietly. I don't know why, if he is present in or not.
No, sir. I'm here only.
So help us.
Sir, this problem is too much big and too confusing problem.
It's not at all a confusing problem. I am making you understand. I am also actually recording.
Yeah, sir. Sir, I am just understanding because the calculation is too much huge.
Okay.
I'm just seeing it.
Okay. Aditya Shom Chaudhary, help me, please. Aditya Shom Chaudhary, please help me.
স্যার লিখলাম তো স্যার
আর 4 নম্বরটা লিখবে না?
4 নম্বর।
সব লিখে দিয়েছি স্যার।
ওটা
4
লিখেছো?
নম্বরটা লিখছিল।
4 নম্বরটা লেখোনি তো? তুমি যেটা লিখলে সেটাই তো লিখলাম।
4th রো যেটা।
4th row।
স্যার প্রথমটা 690।
আমি জানি না 690 হবে।
হ্যাঁ তাই আসছে 690 আসছে।
Okay. Then this is called group work.
930 to 10.
750.
Then
930 to 330.
স্যার এটা তো 6 ঘন্টা হয়ে যাচ্ছে।
আচ্ছা, which one? Tell me. Okay, I'm helping you.
930 to 330.
930. আচ্ছা, then it is
6 ঘন্টা হয়ে যাচ্ছে।
6 hours. Then it is all right. Take 6 hours. 6 hours. Okay. The 9:30, 10:30, 11:30, 12:30, 1:30, 2:30, 3:30. 3:30. So 9:30 to 3:30.
6 ঘন্টা হয়ে যাচ্ছে স্যার।
হ্যাঁ, so okay, then 6 into
60.
that means 360.
360. 930 to 8.
স্যার এটা 690 হবে লাস্টের।
লাস্টেরটা কত হবে?
690।
690 sir.
No, how? No, 690 how? It is 9:30 p.m.
Oh, sorry.
It is
Out
8 p.m.
23.5.
Oh, you have done one thing wrong. Yeah. It is 9:30 p.m. and this is 3:30 p.m. It is not a.m. p.m. It is not. হ্যাঁ, বেশি হবে। বলো। ঠিক বলেছো।
Oh, sir.
p.m.
স্যার 16 into 6 হবে তাহলে।
বলো কত আসছে?
$960.
Is it all right, others? 9:30 p.m. to 9:30 p.m. at night to the next day's 3:30 p.m. of the afternoon. So 3:30 p.m. Remember, it is not a.m. So 12:30, 10:30, 11:30, 10, 11, 12, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 1, 2, 3:30. 18 into 60. How much?
1080.
Yes, 1080. And what is the last one?
1080 sir.
Last one?
স্যার
Sir,
আমার আছে
1410.
স্যার আমার 1110 আসছে স্যার।
18.5.
1410.
0.5
Let us check. 9:30 p.m.
1080 হবে।
1080
Yeah, okay. What is the last one?
1410.
9:30 9:30
141.
9:30 p.m. of tonight.
Sir,
Two-
23.5 hours into 60.
Yes, how much?
1410.
14, yes.
1410.
1410.
1410, sure.
1410. Yes.
हाँ sir.
Yes, sir. Yes, sir.
Yes, sir.
Also.
Yes, sir.
Just a minute. 10:30, 11:30, 12:30, 10:30, 11:30, 12:30, 1:30, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 19 minutes, 22.5 into
No, sir,
60.
sorry sir.
22.5 into
1350 এটা.
uh-huh.
1350. 1350.
1350.
1350.
हाँ sir, 1.5 ঘন্টা থেকে আধ ঘন্টা ধরে ফেলেছে।
হ্যাঁ হ্যাঁ now see now please don't be your first job is done. Please don't be angry with me now because I am going to construct table 2. Please do not get angry with me for today. This is my last class before vacation. Table 2. Crews are situated at Kolkata now. I shall not do the assignments. Assignments will be left for you. I'm just trying to help you to construct this matrix. That's it. Once we get the matrix with our with our known structure, then I shall leave the classroom. I'm not going to finish the problem. I'm just going to helping you out to solve this particular problem to mathematically modeling of this particular problem, because this particular problem, a part of this particular problem will be there in the continuous evaluation too. So you see, you connected this to that. Okay, we should not write 101 in the row wise and 1 2 3 4 in the column wise, otherwise the structure of the matrix will be changed. So in that case, what you are going to do, you write the pattern of the matrix in the same manner. In this particular table, you connected this column with that column, this arrival column with that depart column. Now we are going to connect this arrival column with that depart column, because Kolkata to Delhi, you are going to from Kolkata to Delhi, and then you are laying over there for 6 hours, and then you are starting from Delhi and you are coming back to Kolkata. Okay, so now you have to connect this arrival with that depart in a similar manner. So do it and tell me the matrix values. After the construction of the matrix, I am going to do something by myself. I will not give you headaches anymore. This is the last stage performance you are going to make in today's class. After that, I will get into the picture and I will construct a matrix quickly, very fast on the right hand side, and that will be our assignment. That will be our matrix on which the assignments will be made. Okay, so table number 3 is left for me. Table number 3 will be done by me. I will do it. You just do it. You just help me with table number 2. Because I know that we started the class at 3:15 and now it is almost 2 hours. So you are tired. Please, if you take this pain for today, then there will be no pain anymore. You will be happy. This will be benefited. Tell me, I'm waiting for your replies. Meanwhile, try to do 1 or 2 values by myself. 11 a.m. to 7 a.m. Tell me, are you getting this? Are you getting this? Hello?
Yes, sir. Counting. Wait.
My first value has come out to be 1200. Remember, you are to connect this with that. This with that.
স্যার পরেরটা 1440।
I don't know, maybe 1440. Okay.
হ্যাঁ স্যার 24 ঘন্টাতে হচ্ছে।
1440.
হ্যাঁ স্যার 24 ঘন্টা হয়ে যাচ্ছে তো এটা।
দেখি দাঁড়াও। 11 AM to 9 AM. 11 AM to 11 AM is
arrive to
24
arrive
hours.
করে ফেলেছে।
22 hours.
না 22
Hmm.
1320।
Okay, that is eta 1320. Now next 1320. Okay. No, yeah, 11 AM to 9 AM. 11 AM to 11 AM is 24 hours. And 2 less is 22 hours. So 22 into 60. Yeah, 1320. Okay, fine. Then
পরেরটা 1590।
1590. Then the first value, I have calculated first value to be 1200. It was all right.
হ্যাঁ স্যার
Yeah.
ঠিক আছে।
Second value is from 11 AM to 11 AM. That is 2400. 11 AM to 9. Oh, just a minute.
11 AM to 7:30 PM।
11 AM to 7:30. 11 AM to 11 AM to 1:30 PM. How much? 11 AM to
আড়াই ঘন্টা হচ্ছে তো, আড়াই ঘন্টা না?
আড়াই ঘন্টা
আড়াই
হচ্ছে।
ঘন্টা।
আড়াই, হ্যাঁ, মাল্টিপ্লাই বাই 24 হবে তো।
কেন 24 হবে কেন?
পরের দিন হচ্ছে তো 26.5
11টা থেকে পরের দিন 11টা পর্যন্ত হচ্ছে তোমার 11টা AM থেকে পরের দিন 11টা AM পর্যন্ত হচ্ছে 24 আওয়ার্স। আর তার সাথে আরো এক্সট্রা অ্যাড হচ্ছে
আড়াই
ঘন্টা।
আড়াই মানে 24 plus
26.5।
26.5
6.5
26.5 into 60 1590 ঠিক আছে
1590
ঠিক আছে,
হ্যাঁ হ্যাঁ স্যার ঠিক আছে।
ঠিক আছে
স্যার তারপরেরটা হচ্ছে
বলো তোমাদের এবার বুঝতে পেরে গেছো
510।
হ্যাঁ কত 510
510
510
হ্যাঁ।
others please check somebody is playing disco I think
স্যার আমার ভাই বাজাচ্ছে।
তো তোমাকে মিউট করছি দাঁড়াও where are the students other students girl students where are they let me see let me check Akash,
1260
which one?
পরেরটা
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 1260. This one 1260. Okay. Sumona has gone quiet. Akash Gupta quiet. অরুণিমা
ভালো লাগছে না।
ভালো লাগছে না। আচ্ছা একটু একটু কষ্ট করে নাও, একটু কষ্ট করে নাও।
স্যার আমি নাম্বার 4th রোটা করছি স্যার।
হ্যাঁ ভালো, এটাই এটাই। তোমরা যদি সবাই একসাথে গ্রুপে করো তাহলে খুব ভালো হবে, তাড়াতাড়ি হয়ে যাবে।
একের যেটা মানে 104 যেটা আছে সেটা 510 এর জায়গাটা একটু বোঝাবেন আরেকবার? আমার অন্য ভ্যালু আসছে, তার জন্য একটু
তোমার
problem
কত
হচ্ছে।
ভ্যালু আসছে শুনি একবার,
510
কত এসেছে তোমার?
স্যার আমার 1890 আসছে।
না না, এটা দেখো
11 AM থেকে 7:30 PM আছে।
সেম ডেতে ভাই, ওটা সেম ডেতে।
সেম ডেতে হয়ে যাবে না। 11টা থেকে তুমি কাউন্ট করো, 11, 12, 1, 2, 3, 4, 5, 6. It's more than 7 hours. So it is of the same day because minimum labor time is getting increased. Same day. So it is actually 7.5. 7.5 hours.
Say 8.5.
8.5.
8.5 hours.
8.5 hours multiplied by 8.5 hours multiplied by 60. That's why it is 510.
Okay, sir.
Sumona, just 5 minutes. Don't worry. Just 5 minutes. Everybody is trying. Just 5 minutes.
স্যার টেবিলটা একটু দেখান।
Oh, one thing. Acha. Just a minute. Wait. Your calculation is all right, but I have to, because exactly. Sorry, this is actually. You remember these values, okay? 13201590 Remember these values. One mistake is there. Let me tell. What was the value? What was that value? Tell me. What values I have erased?
Sir, 1260.
1260
After 1200 we got which value?
1260
1320.
13. That will be written over here, not row wise. I'm telling you why. And what was the next one?
1590.
Yeah, exactly. I made a mistake at this point.
কেন স্যার এটা?
বলছি এটা 5110 এটা হচ্ছে because I am, although I have not changed the structure of the matrix, I have not changed the structure. I kept 1 2 3 4 over here and 101 1 2 101 102 over there, but actually you see what is happening. I am associating 101 with 1. You are in 101 and 101 is becoming 1, 101 is becoming 2, 101 is becoming 3, 101 is becoming 4. Previously the process was different. It was 1 was becoming 101, 1 was becoming 102, 1 was becoming 103, 1 was becoming 104. And now it has reversed because you are now situated at Crew is it on Kolkata, has gone to Delhi. So that will be, direction will be like this. Your matrix may be not, you have not changed your matrix, but your direction will be column wise, not row wise. Everything else is all right. Calculation is perfect, but your direction will be column wise. That's why. So tell me these values. You are calculating exactly all right. Tell me, 1140. Yeah, that is 1140. Okay. Now tell me other values.
টাইম টেবিলটা
কি
টাইম টেবিলটা স্যার আগের স্লাইডে টাইম টেবিলটা
Okay. Because you have to, previously you were filling up the rows, now you are going to fill up the columns. 101 to 1234, 102 to 1234, 103 to 1234, 104 to 1234, like this. Previously it was 1.
স্যার 1380
Okay. Which one? This one?
হ্যাঁ
No. Sure. 102 to 2. 102 to 2 means 12 noon to 9 a.m. 12 noon to 9 a.m. It is a noon. This is noon.
Sir, 1260.
Okay, then
Sir, 1650.
12 noon to 1:30 p.m. 1:30 p.m. of not that day, next day. 12 noon to 1:30 p.m. that is of next day. Others, please help.
Sir, 1530.
Okay, then next is 12 noon to 7:30 p.m. 12 noon, first of all, you try to find whether what is the difference between 12 noon and 7:30 p.m. If it is 6 hours, then take the same day. If it is less than 6 hours, go to the next day.
450.
Okay. That means the same day. Okay.
Same day.
Okay. Now you connect. You connect. Next is how much? 5:30 with 7 a.m. 5:30 p.m. with 7 a.m. 5:30 p.m. with 9 a.m. 5:30 p.m. with 1:30. 5:30 p.m. with 7:30. Sumana, don't worry. Just bear the pain for today only. I money
810.
8:10. Okay.
10. 810.
হ্যাঁ, তুমি একটু শুয়ে থাকো, একটু শুয়ে থাকো দেখো।
না না, বসে আছি, ঠিক আছে।
আচ্ছা আচ্ছা। I'm actually counting the hours. I'm not actually multiplying by 60. So therefore, whenever you give me the value, I'm just relating
930.
930. Yeah, okay. Two people are saying 930, then it is all right. Okay, then
Sir, 1200.
okay, 1200. Next.
Sir, 1560.
1560.
Okay, last column.
Sir, last column is 540, 660, 930, 1290.
540, 660,
660, 930, 1290.
Others,
Sir,
please.
ছুটি তো এখন।
Now, just a minute. I'm just 1 minute. You are not going to make assignment on table 1 or table 2. You are going to perform Hungarian method. You are going to perform Hungarian method on table 3. Hungarian method on table 3. And how to get your table 3? See, in the question it is written that for any given pairing of the crew will be based on the city that results in the smaller layover. Okay, that means you have got for this cell, say 1 and 101. For this cell, you have got two different values. In the table 1, you have got 1440. In the table 2, we have got 1200. Two values are there. So which one is minimum of these two? 1200 is minimum, so your cell value will be 1200. Okay, so you will put a star mark over here. And then 1500 and 1140. So you are going to put 1140. And you are going to put a star mark over there. Okay, then next is 390.
The minimum we will put in the new table.
Yeah, minimum of the two will be taken in the new table.
Okay,
so
sir.
Previous is, this one is 390 and that was is 810. You are going to put 390 and then you are going to put a star mark over there in this matrix. These star marks are very important. Similarly, 660 and 540. So I'm going to put 540 and I'm going to put star mark over there. I will tell you why star marks are being taken. 1320 and 1320. Both are same, 1320 and 1320. So you can take any one of these two. So let us do this. So you will put a star mark here also and there also. Okay, fine. Then 1380 and 1260. So we are going to put 1260 and then we're going to put a star mark like this. Then we have 1710 and 930. So we are going to put 930 and we are going to put a star mark. Then 540 and 660. So we're going to write 540 and we are going to put a star mark like this. 1050 and 1590. We are going to put 1050 and star mark over there. Then 1530 and 1110. So we are going to write 1110 and we are going to put star mark over there. 1440 and 1200. We are going to put 1200 and star mark over there. 930 and 1700. We are going to put 930 and put a star mark over there.
510, 510, 450, 1080, 1290.
তারা শুধু এরকম বললে হবে না, আমাকে স্টার মার্ক গুলো দিতে হবে। 450 বলছো, ঠিক আছে। 450
1080
1080 মানে আগেরটায়।
1290।
আকাশ গুপ্ত আজকে খচে খ হয়ে গেছে পুরো। 1350 1290 1290 বাস। নাও দ্য
ছুটি তো
ছুটি বাট star mark okay just 1290 কোথায় star marks okay now the finishing statement of today's class, just finishing statement. Perform after performance of Hungarian method, and once you get the assignment, so what will you get? We are going to assign something in some way. We have this, we have flight numbers, flights 1 2 3 4, and we have flights 10 101 102 103 104. Now you see the last line, what is written: for each pair also mention the town where the crew should be located. So you, after assignment, you will find that sometimes you are sometimes you are taking the value, sometimes you are taking the time from either this matrix table 1, or sometimes you are taking the time from table 2. Okay, so that will happen, and depending upon that you are going to select. That means what? If you are going to, suppose you are going to assign 1 to 101. Suppose imagine you are going to get an assignment like this. That means the corresponding value will be 1200. Okay, and that 1200 was actually from which particular table you got 1200? You got 1200 from table 2, and so therefore your answer will be my crew is based on Kolkata. So you try to finish this particular problem. I'm very much thankful to you for your extreme patience. Finish this problem.
Okay sir, no problem.
Okay, try to finish and we'll discuss further after the vacation. So Merry Christmas and Happy New Year in advance.
Same to you, sir. Thank you, sir.
Yeah, okay.
Bye, sir.
Thank you,
Bye.
sir.
Good night.
Bye. Bye. Good night.
Thank you, sir.
Yeah.